All right, so again, Newton's first and second law says, if the net force is 0, what do you know is happening to this thing? No acceleration. And if it has a net force, then it has to definitely be. This is not a new thing, right? You know this. Okay, so now let's see how we're doing. Whoa, that's a really big picture. Let me try and make it a little smaller so that it doesn't look quite so frightening to you. I love these, and when you take AP Physics with me, you're going to learn that I love them a lot. Like, we do like 4 of them a day, because they're so, everyone's like, whoa! Like, for real. Because they're really good, and they really make sure that you understand physics. What? All right, so let me tell you what's going on back here, up here. All the trailers and cars shown are identical, but the boat trailers have different flows. In each case, the car and the boat trailer are moving at the constant speed shown. So what this asks you to do is to rank the magnitude of the net force on each trailer. Okay? So you'll write something like A is greater than B is greater than C is greater than D. That's not the right answer. Or maybe it is. I want you to think about it right now. You and your brain will like think for a moment, and then I will discuss. So this is quiet moment for you. So, Aaron is very modest, and I think she knows the answer. Is that true? Yes. I don't know what you said. What did you guys say back there? We said that they were all 0. So that they were all 0. Now, I will tell you that the most important is not just the answer, but it's the explain your reason. So, well, they're all traveling at a constant speed. They wouldn't have any acceleration. And since f net is mass times acceleration, f net would be 0. What do you guys think? Did everybody get that? Yeah. Sweet. I love it. Yes. All right. Then we're ready to chapter 7. Hey, Trayton. Go on the floor. No. No abuse. No. Here we go. Here we go. That's really like draw a picture. Dump this water. So we dump it on him when I'm doing. I want to draw a diagram. The cup or the cup. Go ahead and draw a free body diagram of what was going on. This is you and your brain. Shh. I would like to. Okay, so when it's at the bottom, we all agree that there's you agree? Yes. So, good kids, chapter 4. Going to source of the earth going down, right? The source of the earth. And I know that some of us have gotten a little bit lazy with that, but I need this with the chapter. What else did you have? What else did you have? Upward force. So the force of the string on the cup. Now, if you need another 10 seconds, okay. Okay. All agree
Yes. Yeah.
down. What is it? Do we agree?
Yes.
Okay. Down. Up. String force. Down. Gravitational. It's got electromagnetic. The weak force. Nope. Nope. Contact force. Is there a contact force acting? Yeah. So no. It's not. It's mag. Like that. What? Be something pulling. If you want to play down here, this you want probably not. Probably not. It's gonna die. It's not. And the net force pulling down here. Good thing. Is moving, and that's important. Line, right? Accelerating. That's good. Life is okay so far. Notice we haven't used any bad words yet, Jake. Just saying. All right. This is kind of like a ranking task. It's not the same. Riley, if you want to look at this one, it's in the B2 section. It's number 26. You'll be able to find it. Let me explain this one to you, just so you understand what's going on. You've got a car traveling clockwise in this direction, okay, around an oval track. In the table below, indicate the direction of the velocity and of the acceleration of the car for the labeled point. So here are some different direction choices. Does that make sense? And it just wants you to find or look at R, S, T, U, and V, and maybe W also. Let me look. Yeah. Hello. Yes, and W. So I'm going to make this really big so you can see the picture. Okay. So make a little chart on your paper. I want to know the direction for the velocity and for the acceleration in each of these cases. Also, really quickly to note, if there is no direction, no velocity, or no acceleration, use the letter J, and use M if none of them are correct. So J means no velocity or acceleration, and L means none are correct. Okay. I'm going to give you a minute to work on that by yourself, and then we'll discuss it in your groups. Take a look. Again, it's moving clockwise around the track. This was a thinker question. Oops. Right? So as this object is moving in a circle, I'll get you. The velocity is tangent with touching at one point. Tangent also means perpendicular to the radius. Straighten my leg. Now, if there is tangential velocity, oops, you missed CC. Let's take a look back here now. So the velocities we agree with. Now let's think about it in acceleration. That one of two things happening. What's one of them? It's turning. It's changing direction. Changing direction. So acceleration means either that we're changing direction or what else? Somebody else. So, changing speed. There you go. Is everybody okay with that? At R, are we changing velocity? Or are we changing speed? Are we changing direction? No. Are we accelerating? Yes. Think about it in terms of the way I asked. Are we accelerating? If we're accelerating, that means we're changing direction or changing speed. Are we changing direction at all? Are we changing speed? No. So, what should it be at all? J. If it was like in between or something. How about at U? Are we accelerating at U? No. No acceleration at U, so the answer should be J as well. All right, so we're good there. Let's look at S, T, U, and V. Or excuse me, S, T, V, and W. Is there acceleration? Yes. Is the no. It's all about direction. Now I want you to put understanding what that means to you. If it's accelerating, that means that there has to be a what acting? Push or a force. A force. A push or a pull, right? Where is the push or pull going? The velocity, we know, is going down like this. I want you to think about this. Don't say it out loud yet. If this thing is staying in a circle, where does the push or pull have to be active? I'm not going to ask for an answer yet. I want you to look at it. I want you to understand. I want you to think about it. I want you to talk to your table mates. Where does it have to be active? If you think you have an answer, erase your whiteboard and put the answer on your board really big on one side. Not the same person that just drew something else. Share the marker, share the fun. No. Talk to me. That makes sense. And I don't allow you to not make sense. In this case, this thing, when it wants to go this way, make sure you're not walking. Walking this way, this way, or the directions you want to go. The directions you want to go, right? Right? The direction it wants it to go. The string is pulling on the block and the direction it wants it to go. What's keeping the car in close? Yeah. In this one. Or no? Okay. Really? Do another. With your partner. That's what on the next one. I want to put letters. Letters S, V, and W. S. Walking down the hallway. I don't know, somebody pulls on her because they that's the they want her to turn. Which way are they going to push on? In towards the center. I mean, I should have been changing these along. This would be G. What's the matter? Yeah, it is. The center of this circle? F goes like that. That's the center of the circle. Is that okay?
Yes.
Okay. V. What does that say? B. Yes? B. Towards the center of the circle. And W? C. Towards the center. Okay. Now, Jake, I don't want you to leave before you leave. And it's not just you. There's other people too. So let's be very clear. When something is moving in a circle, we know that it must be accelerating, right? We know that that acceleration is always pointing, I don't want to say in the same direction, but always in a with a common theme. It's always where? Towards the center of the circle. Now, we can call that acceleration something special. That acceleration is center seeking. Okay? It's like that friend that's always pulling on you toward the center. There's a fancy word for that, and that fancy word is centripetal. Centripetal. Centripetal means center seeking. Center seeking. Okay? The word that my friend in the front said out loud that I kind of forgot about, and I will for the rest of my days. I forgot about this one. One more time, it's allowed to be uttered in the room. One more time, Jason, say it one more time. What was the word? No. What word did you actually say? He said, no, last time I don't want to hear it anymore. I want you to know why it's wrong. Centrifugal means center fleeing. Center fleeing. That would imply that there's a force that's pulling outward. Is there an outward force causing something to move in a circle? No. This does not exist. Write it from your vocabulary. You can remember the F word, right? Don't say it at all. We'll put the message. Have a good day, guys.